In this video, we're going to work through a few different questions on fractional and negative indices. And if you haven't seen my video on fractional and negative indices, I'd recommend you check that out before attempting these questions. So our first question tells us to simplify the cube root of x squared divided by the square root of x. Now, what we want to do is transform this sum into something that we are more familiar with and we can deal with simply. So what I'd recommend you doing first is transferring our exponents into fractional exponents, because we know that roots can be expressed as fractional exponents. Now, we know that the cube root of x, like such, is the same as taking x to the power of a third. And so if we have the cube root of x squared, then that means that our numerator, the number on top, becomes whatever that number is. So if that was a cube, that would become 3, and so on and so forth. So x to the power of 2/3 is the same as the cube root of x squared. Okay, so we're going to drop that down here. And then if we have x, the square root of x, that is the same as saying x to the power of a half, because we've got a 2 here, and that is the same as what is in our denominator. So we can express this equation as x to the power of 2/3 over x to the power of a half. Now, when it's in a format like this, that is just the same as taking a division. So x to the power of 2/3 divided by x to the power of a half. And as we've seen from our laws of indices, we know that when we have the same base, which is x here, and we have exponents, we can simply take them away. So this is the same as saying x raised to the power of 2/3 minus 1/2. And this is more basic mathematics, but if we have 2/3 minus 1/2, what we want to do to be able to actually take away when using fractions is that we want the same denominator, okay? So we need to find a number that we can multiply and they both go into, so 3 times 6 would both go into both numbers, so 3 times 2 is 6 and 2 times 3 is 6. So if we multiply both sides of this by 2, that's going to give us 4/6, and if we multiply both sides of this by 3, that's going to give us 3/6, and therefore we can just take away our numerators, which is 4 minus 3, and that equals 1, and we're going to keep our denominator the same, which is 1/6. And therefore, our final answer then, x to the power of 2/3 minus a half, is the same as x to the power of 1/6, and that is our final answer. So this question's a slightly more tricky, but given that y equals 1/16 x squared, express y to the power of the half in the form kx squared, where k and n are constant. So we know that y equals 1/16 x squared, and we've got to use this y to the power of a half. So what this is really telling us is that we've got to substitute y into y raised to the power of a half. So let's do that now. So y raised to the power of a half is equal to y, which is 1/16 x squared raised to the power of a half. Okay, now we should know that from our law of indices that when we have a bracketed expression raised to a certain power, we apply or multiply each of the terms within our expression in the bracket by the power outside the bracket. So really this is the same as taking 1/16 to the power of a half and x squared to the power of a half. Now, this may be a little bit complicated if you're just starting out, but don't worry too much, because all this is telling us is to take the square root of everything inside the 16th and the square root of x squared. So after all, x to the power of a half is equal to the square root of x. Okay, so the square root of 1 is just 1, because 1 times 1 is equal to 1, and the square root of 16 is 4, because 4 times 4 is equal to 16. So 1/16 raised to the power of a half is simply 1 over the square root of 16, which equals 1 over 4. And x squared to the power of a half is, well, if you remember from our laws of indices, we simply have to multiply together the exponent within the bracket and exponent outside the bracket. So that's the same as taking x squared times half, and 2 times half is the same as saying 2 over 1 times 1 over 2, and that is equal to 1. So x squared to the power of a half is simply x, and that gives us our final answer. Our final question tells us to evaluate 343 over 512 raised to the power of negative 2/3. And to answer this question requires us to use a couple of different areas of knowledge from the laws of indices. Now, the first thing that we really want to do is to get rid of our negative symbol. And to do that, we want to find the reciprocal of the fraction. In other words, we want to flip the fraction over. And by doing so, we can just remove the negative symbol. So let's find the reciprocal of 343 over 512. And that is simply equal to 512 over 343. And we can now remove the negative symbol from our exponent as such. And if you remember just from the previous example, is that when we have an exponent applied to a fraction, that exponent applies to both the numerator and the denominator. So this would be the same as saying 512 raised to the power of 2/3 over 343 raised to the power of 2/3. And whatever is in the denominator, so our 3's here, is what the root is going to be. So 3 would be the cube root, so we need to find the cube root of 512, and the numerator, so the top number, would be to what power we apply the base, which would be squared. In other words, 2/3, 512 to the power of 2/3 is the cube root of 512 to the power of 2. And we've got the same power in the denominator here, so we need to find the cube root of 343, and that's also to the second power as well, because we've got the same exponent in both the numerator and the denominator. And you can then plug those into your calculator exactly as I've written it down here, and you should get a final answer of 64 over 49. And that is it. If you have any questions about this video, then please leave a comment below and I'll get straight back to you. But if you enjoyed the video, make sure you like the video and subscribe to my channel. Thank you very much for watching.